Hello everyone. So this is the next class of this thermodynamics lecture 2. Okay. So in the first class I will discuss heat, work and energy and their significance, first law of thermodynamics. Today I will discuss entropy. Okay. So what is entropy? Entropy is the degree of randomness. Next, it is an extensive property and it is a state function. Okay. So as it is an state function, we cannot calculate this exact value, but it is calculated the change of entropy, that is q reversible by t. The unit of entropy is joule per Kelvin or calorie per Kelvin. For isothermal process, that is at constant temperature, T1 is equal to T2. So delta S is equal to 2.303 nR log of V2 by V1. Or you can say that for ideal equation PV is equal to RT. So you can replace this V2 and V1 by P1 and P2, and delta S is equal to 2.303 nR log of P1 by P2. For isochloric process, that is volume constant, so V1 is equal to V2, delta S is equal to 2.303 n Cv log of T2 by T1. Cv is equal to heat capacity, specific heat at constant volume. Next, adiabatic process. For reversible adiabatic process, Q reversible is equal to 0, so delta S is equal to 0. For reversible adiabatic process, irreversible adiabatic process, Q is equal to 0, delta S not is equal to 0. For cyclic process, delta S is equal to 0. Reversible process, delta S is equal to 0, and irreversible process, delta S not is equal to 0. These are very important for exam point of view. Next, this box is very important. That is delta is greater than 0, that is spontaneous process, delta is less than 0, that is non-spontaneous process, and delta is equal to 0, that is equilibrium. Next, Gibbs free energy. This is the part of energy which is converted into useful work is called free energy. Okay, so H is equal to G plus Ts, that is enthalpy is equal to Gibbs free energy plus temperature into entropy. Okay, so if we rearrange this, you can get G is equal to H minus Ts. As it is a state function, I told previously that as it is a state function, we cannot calculate absolute value of G. So we can calculate change in Gibbs free energy. Okay, so delta G is equal to delta H minus delta Ts. That if we get partial derivative of this, then delta G is equal to delta H minus delta Ts plus T delta S. Okay. As Gibbs free energy is calculated at constant temperature and pressure, so delta T is equal to 0, hence delta T dot S, this part is equal to 0. So delta G is equal to delta H minus T del S. This is the equation of Gibbs-Helmholtz. Okay. Next, Gibbs free energy and spontaneity of the reaction. From this equation, that is delta G is equal to delta H minus T delta S, we can conclude that this is very important for exam point of view. Delta G less than 0, process is spontaneous. Delta G less than greater than 0, that is non-spontaneous process. And if delta G is equal to 0, then it is equilibrium. Next, from this equation, if we take the value delta H and delta S, so it can conclude the delta G either positive or negative, and I will discuss that it is spontaneous or non-spontaneous reaction. If we take delta H is equal to positive and delta S is equal to negative, from this reaction, if we put these values positive and negative, then delta G is equal to positive. So always it is a non-spontaneous process. Next, if take delta H negative value and delta S positive value, then delta G is equal to negative. So always spontaneous process. Next, if we take delta H is equal to positive and delta S is equal to positive, then delta G is equal to negative. So at high temperature, it is a spontaneous process. Next, if these are two positive, then delta G is equal to positive at low temperature. This is non-spontaneous process. Okay. Next, if we take delta H and delta S is equal to negative value, then delta G is equal to negative at low temperature. It is spontaneous process. These are very important. These are oftenly asked in the exam. Next, second law of thermodynamics. According to second law of thermodynamics, entropy of universe is increasing continuously due to natural process. Hence, delta S universe is greater than 0. So, delta S universe is equal to system plus surrounding. So, delta S system plus delta S surrounding is greater than 0. Next, relationship between delta Z 0 and equilibrium constant, that is K. If we give an equation, delta G is equal to delta Z 0 plus 2.303 RT log of Q. If we that is C plus D. If we take this equation, then Q is equal to concentration of Q is equal to concentration of C, concentration of D by concentration of A and concentration of B. Okay. So next, at equilibrium, delta G is equal to 0. So Q is equal to K. K is equal to equilibrium constant. Hence, if we put this value delta Z is equal to 0, then delta G naught is equal to minus 2.303 log of K. Okay. Next, K, if we take ln, that is ln is equal to ln is equal to 2.303 log. Okay, if we put this value, K is equal to e to the power minus delta G 0 by RT, or K is equal to 10 to the power minus delta G 0 by 2.303 RT. These three equations are very important for numerical problem. Next, relationship between delta Z and EMF of the cell. I will discuss these topics in electrochemistry. Delta G is equal to minus NF E cell. N is equal to number of electron, F is equal to Faraday constant, E is equal to EMF of the cell. Delta G 0 less than 0, delta G less than 0 and EMF of the cell is greater than 0. Next, Hess law, it states that heat change during reaction is same whether it takes place in a single step or in multiple step. Okay. So if we take a general example, that is A to B, it is a single step reaction. If we take this is multi-step reaction, A to C, C to D, D to B. That is for single step reaction, the enthalpy change is delta H, and if we take an example multiple step, then first step is enthalpy change delta H1, next delta H2, next delta H3, then delta H for the single step reaction is equal to the delta H1 plus delta H2 plus delta H3. If we give an example, then C plus O2, for the single step reaction, the enthalpy change is minus 93 kilocalorie. But if we take this step by two steps, then C plus half O2, that is CO. For this process, the enthalpy change is minus 68 kilocalorie. And if we next step CO plus half O2, that is CO2, for this step the enthalpy change is minus 25 kilocalorie. For these two step, if we sum the values, it will be equal to minus 93 kilocalorie. Okay.